The low-temperature differential Stirling engine is a closed-cycle regenerative heat engine. It interconverts heat and mechanical energy using temperature differences that are less than 100 degrees Celsius. It's a closed cycle because the working fluid, which is the air, is permanently enclosed in the engine, and it is regenerative because a portion of the heat discarded in one cycle is saved and used for the next. The air is enclosed in a pair of connected cylinders, the displacement cylinder and the compression cylinder. The displacement cylinder has two metal ends, one on top and one on the bottom. These are the two plates which are held at different temperatures to operate the engine. Inside the displacement cylinder is a loosely fitting piston that moves air between the end plates and stores heat. Inside the compression cylinder is a tightly fitted power piston that compresses the air in the cylinders and also drives the flywheel. A pair of connecting rods links these two pistons, keeping the relationship between the two displacements correct. The setup for the demonstration is very straightforward. You can use a hot cup of tea or coffee, but I just have some water here. Now, I'm not scathing. It is warm, but it's not like a bubbling flask of water that you need. You place this on top of your water. Give it a moment for it to heat up, because you do have to have a difference in temperature. And then give it a little starting push. One thing to note, you want to make this go clockwise. To continue moving, it will not work if you try to make it go counterclockwise. The low-temperature Stirling engine allows students to investigate PV diagrams, conservation of heat, and mechanical energy. The clear design makes it very easy for students to see every aspect of this wonderful little machine, and plus it just makes a very, very cool centerpiece to help engage students in how cool science can be.